So now we're going to look at perfect square trinomial, the other part of Rule 2. So let's look at this. Any greatest common factors? Well, no, this one doesn't even have a letter. This one doesn't even have a number. So rule number 2, is it a binomial? No, so we know it's not a difference of squares. Is it a trinomial? Yes, so we keep going on with those questions. Question number 7, is this a positive? Yes. Okay, then the next one, can I get an even square root of n squared? Yes, that's n. That didn't look much like an n, but... And then I go to the last one, can I get an even square root of 49? Well, yeah, that's 7. Now, we just in the last video did this, okay? And we said x is n and y is 7. Okay, once we did this for the difference of squares, we knew we were done, and we just put it into the pattern. Here, even though we did the exact same thing as that, we have one more step, because in a perfect square trinomial, if you look on your factoring rules sheet, the middle term in a perfect square trinomial is always 2 times x times y. So that I need to check that middle term first. So I'm going to go 2 times my x times my y, multiply these up. So 2 times n is 2n, and 2n times 7 is 14n. And that's what this is. So I just answered yes to all the questions. That means this is a perfect square trinomial. Now, if this had come out, let's say we got all the way down to here, and this had come out to 14n, but this was 15n, then it's not a perfect square trinomial. You also are not done. You just go on to Rule 3a in this case and keep working. But since this is a perfect square trinomial, we just go into the pattern, which is one set of parentheses with a square. We put our x, our y, and whatever sign this is goes in right there. And we're done. Now, I'm going to prove to you that this works every time again. I don't ever want you doing this the long way. You could use Rule 3a or 3b on these. Do not. You must recognize this as a pattern and go directly to it now. So, we're going to check this. This is basically, unlike, a difference of squares where our x's are the same and our y's are the same but our signs are different. In a perfect square trinomial, our x's are the same, our y's are the same, but our signs are the same. That's why we write it like this, because we've got two of the exact same thing. So again, I'm going to do this the long way. I don't ever want to see you doing that. So n times n is n squared. That's negative 7n. This is negative 7n. Negative times a negative is a positive. 7 times 7 is 49. So look at this. Remember, I'm always saying in a perfect square trinomial, this last sign is always positive, because these two, negative times a negative is a positive. If these were both positive, positive times a positive is a positive. That's why that's always positive. Now let's look at our middle terms. These are exactly the same. How many of them do I have? Oh, I've got 2 of them. And to get them, I multiplied x times y times y times x. So I've got 2 of them. When I add them together, and there's my perfect square trinomial. So you should be able to recognize this, go straight to this. Or from 3.1 when you learn this, you should be able to recognize this as a perfect square trinomial and go straight to this. I think I have another couple of, just to practice. 3 plus 24 number 1, any greatest common factors? Well, I've got 4p, that leaves me with p squared plus 6p plus 9. Now I need to look at what's left. Is this a binomial? Nope. Is it a trinomial? Yep. Is this positive? Yep. So, oops, I didn't want to do that yet. Can I get an even square root of p squared? Yes. Can I get an even square root of 9? Yes. Remember, because this is a perfect square trinomial and not a difference of squares, I have to check my middle term. 2 times my x times my y. 2 times p times 3. Well, that's 2p times 3, which is 6p. That's what this is. So this indeed is a perfect square trinomial. Remember to bring down the greatest common factor you already factored out. Pattern for a perfect square trinomial. 1 set of parentheses squared. My x goes here, my y here, and whatever this sign is goes there. Got one more. See if we can fit it in. Just to help out. 81k squared minus 18k plus m squared. Okay. Rule number 1, any greatest common factors? Nope. This one doesn't have an m. This one doesn't even have a number. Rule number 2, is it a binomial? Nope. Is it a trinomial? Yep. Is this positive? Yep. Can I get an even square root of 81k squared? Well, that would be 9k. 9k times 9k would be 9k squared. Can I get an even square root of m squared? Yep. That's m. Now I need to check my middle term. I don't need to do that on a difference of squares, but I do on a perfect square trinomial. 2 times 9k times m. Well, that's 18k times m gives me 18km. That's what the middle term is. So this is a perfect square trinomial. Just goes into the pattern. My x, my y, this sign goes right there, and I'm done. That's the end of perfect square trinomials.